For y equals f of x equals 2x minus 3, x is 3, and delta x is 4. Find A, delta y for the given x and delta x values. What does that mean, right? So what's happening is they gave you a function, okay, 2x minus 3, and they gave you a starting point of x. So what they are saying is if you start at 3 and if you go up 4, okay, because delta x means the change in x. So if you have the first x value of x equals 3, and they tell you that delta x is 4, the second x value, if I may just write that as x of 2, is this original x value plus the delta x, okay? So what they are just telling you is this is the first x value. First x value is 3, okay? This delta x piece, okay? What this is telling you is the second x value is, and they're not saying the second x value is 4, but they are saying that the second x value is 4 away from 3. Okay? Delta x is the change in x. The change in x is 4. That's why I'm going to add, to find that second x value, I'm going to add 3 plus 4. So we're looking at two x values. The first x value is 3. The second x value is 7. Okay? What they want you to find in part A is change in y. As x goes from 3 to 7, okay? The first x value to the next x value. How much does their y values change? How much does their y values change? That is what part A is asking. Okay, that's what part A is asking. If you want to find y values, we should plug them into the function. So let me find their y values. F of 3, the original y value is 2 times 3 minus 3, which is 3. But if you plug in the second x value of 7, you get 2 times 7 minus 3, which is 11. So what is change in y? Well, change in y is f7 minus f of 3. How much did it change? Well, it went from 3 to 11, so that change is going to be 8. So, first question, delta y is 8. So I wrote a little more than what was really needed because I wanted to explain all these notations and what they were asking us to find in English, right? So as x goes from 3 to 3 to 7, y goes from 3 to 11. That's what part A was asking. Now, part B is asking us to find dy, which equals f prime of x times dx. So I think they're just asking us to come up with this formula. We're not really plugging in these given values. So, all right, hold on. Do I have room? I'm going to go ahead and add another page here and do the second part, okay? So if I want to find dy, which is f prime of x, I don't think you can see what I'm writing, f prime of x times dx, I need to find what f prime of x is, okay? And dx will depend on what x value I pick, what change, the change in x value. So let's find f prime of x first. Remember, they said the function is 2x minus 3, right? So f prime of x is simply just 2, right? The derivative of 2x minus 3 is just 2. So, guess what? dy formula, the differential of y formula, is simply f of x times, which is just 2, dx. So I think that's all they wanted for part B. This is the answer for part B. I'll go ahead and say that. This is, or maybe I should just bring this down and I'll say, and I'll copy the problem name here. I have a strong feeling they're going to ask us to use this to find dy. We already found dy. We already found the change in y, which was 8, right? In part B. But, if we use this formula, we should get something very similar. So, part C. Take a look. I'll copy the wording. Hold on, I'm sorry. I'll bring the part C here. Part C says, oh gosh, come on. Okay, I was trying to make this a little bit bigger, but it's not getting bigger. All right, forget it. I'll just do it. So find dy for given x and delta x value. Well, we just got that dy is equal to 2 times dx. Okay? That means dy is equal to 2 times, and I think they gave us a different notation, but dy is the same as a delta x. And didn't they give you delta x in the beginning of the problem? So let me zoom out. What was delta x? Delta x was 4. So if I plug in 4 there, I get dy equals 8. So you notice this answer d8, dy equals 8, is the same as that delta y we got using the actual y values and subtracting. But this formula that we came up with dy gave us the same answer when we just plugged in that dx, that change in x. So I think it's a good example of showing us that change in y can be found or approximated by finding the differential of y using this formula. And that's it.